In 1963, a computer program written by a student at MIT created a major breakthrough in computer graphics. A student named Ivan Sutherland wrote a program called Sketchpad for his PhD thesis. Sketchpad was the first program to ever utilize a graphical user interface. With Sketchpad, users could interactively draw and manipulate geometric figures directly on a computer screen.
I once asked Ivan Sutherland, how could you possibly have done the first interactive graphics program, the first non-procedural programming language, the first object-oriented software system all in 1 year? He said, well, I didn't know it was hard.
Xerox was the first company to commercialize the graphical user interface, commonly referred to as a GUI, in the 1970s. Their Xerox Alto computer featured a desktop display with overlapping windows and a mouse for user input. Steve Jobs famously toured Xerox PARC and saw the Xerox Alto's GUI, which inspired him to implement it into Apple's products, beginning with the Lisa, then the Macintosh, and later the iPhone.
I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I had ever seen in my life.
In 1982, the movie Tron was released, marking one of the first films to utilize 3D computer graphics extensively. Thanks to significant advances in rendering and 3D modeling techniques, Tron was able to push the boundaries of graphics technology. Fast forward to 2009, the movie Avatar marked another monumental milestone in the evolution of film technology. Avatar significantly advanced the capabilities of 3D computer graphics by leveraging cutting-edge motion capture techniques and high-definition 3D rendering. The film offered a visually impressive experience that was unparalleled at the time. Today, computer graphics continue to advance rapidly. The recent release of Apple's Vision Pro hopes to bring us one step closer to fully immersive digital environments. The Las Vegas Sphere has also captivated the public's attention by using an enormous 16K display to showcase art both inside and outside the dome. As we trace the remarkable history of computer graphics, it becomes clear that each leap in technology has paved the way for even more sophisticated applications. The fusion of art and technology has continually expanded the horizons of what can be visualized on a screen. Today, the process of rendering stands at the heart of this fusion, transforming complex digital models into stunningly realistic visuals. So what exactly is rendering? Rendering is the process of generating 2D and 3D graphics from models using computer programs. The result of applying textures, lighting, and shading to these models can create photorealistic images that are becoming increasingly indistinguishable from what the human eye sees in the physical world. Rendering relies on specialized hardware known as GPUs, which are specifically engineered to accelerate computer graphics and image processing. Advances in GPUs and rendering algorithms allow movie producers and game developers to push the boundaries of what is possible for a digital world to look like. The issue these creators run into, though, is that the higher quality they want the render to be, the more computationally expensive it is to produce. The process to render a movie-quality 3D graphic can take hours or even days on powerful servers. Until recently, content creators had two choices to process their rendering jobs. The first was to buy and build their own infrastructure, and the second was to partner with a rendering farm or cloud provider to rent infrastructure whenever it was needed. Each of these choices has drawbacks, though. Building out your own infrastructure can be very expensive, especially for an individual creator or small company. Major movie studios can afford to build out their own infrastructure, but it is unlikely the hardware will be used at its full capacity 24/7. If they do need more capacity, then they would need to go out and buy more GPUs. Cloud providers and rendering farms provide access to on-demand compute, which can aid in the flexibility and scaling aspects of content creation. However, this flexibility comes at the trade-off of cost and speed. Time-intensive rendering tasks can be prohibitively expensive. Thankfully, content creators now have a third option: the Render Network. The Render Network is a marketplace that sells rendering as a service. Render is scalable, affordable, and fast. Using tokens to facilitate payments and allocate resources, as well as the Solana blockchain to verify rendering tasks and secure transactions, Render has revolutionized how creators can produce content. To showcase a real-world example, the Render team produced the live animations for a 2023 Solana conference using their network. The job took 60,000 render hours to complete. On a traditional workstation, this job would have taken over 40 days to create. Using the Render Network and over 1,000 GPUs, it took less than 2 days to produce the 16K resolution images. Digital artists, musicians, Film, TV, and game studios, and even NASA have all used the render network to produce cutting-edge visualizations. The most well-known example in the crypto space is the digital artist Beeple. Beeple has become famous for producing a new image every day for over 17 years. Beeple uses the render network as a key component in his workflow to produce his images. The ability for artists of all sizes to be able to produce high-quality renders on demand at an affordable cost is a huge breakthrough, which I'm sure will only lead to there being more art out in the world for us to enjoy. With all that said, allow me to briefly explain how the render network operates. The network has three key stakeholders: content creators, node operators, and the render foundation. When a content creator has a job they want to process, they pay for the job upfront in either render tokens or fiat. Node operators supply GPUs to the network in exchange for receiving fees for successfully completing a rendering job. Once the node operators complete a job, they deliver it back to the content creator for approval. If there is something wrong with the render, it enters a dispute resolution workflow to be reprocessed. Once a job is successfully completed, 95% of this fee is paid in render tokens to the node operators who participated in the project. This fee helps to incentivize more users to provide GPU supply to the network. The remaining 5% of tokens are sent to the Render Network Foundation, which is responsible for developing, maintaining, and governing the network. The economic model used by the network is called a burn and mint equilibrium model. This economic model is used by another project called Helium, which we covered in a recent video. In summary, Render has a marketplace of GPUs available to be rented by content creators to process their rendering jobs. This marketplace of GPUs that the network has been able to accumulate has a really interesting benefit. GPUs just so happen to be incredibly useful for artificial intelligence. The release of ChatGPT to the public opened everyone's eyes to the reality that AI is ready for prime time. This has led to a massive surge in demand for GPUs. GPUs are useful in artificial intelligence in a few ways. The first is training deep learning models. Training these models requires a huge amount of computational power to process vast amounts of data, which GPUs excel in due to their ability to perform multiple operations simultaneously. The second is natural language processing, which enables machines to understand and interact with human language, another computationally intensive task. Third, as we've already discussed, GPUs are purpose-built for image and video processing. For AI models to perform object detection and image classification, they rely on GPUs to analyze and process a huge amount of image and video data. Given the supply of GPUs the render network is able to access, these could also be incredibly useful for various AI workloads. Beginning with Governance Proposal RNP4, the render network has added the ability for anyone to build a decentralized AI compute service on top of the network. 4 compute clients have already been added to the network, with 2 more likely to join soon. While the GPUs on Render's network may not be the latest and greatest that are used to train the largest models, there's a long tail of use cases that are able to run on older GPUs. Think of a researcher at a university or a startup programmer. They don't have the funds of an Amazon or Tesla to scoop up the latest hardware from NVIDIA. But time is not a factor for them, so they are able to wait a little longer for their models to train. This need for accessible yet powerful computational resources is exactly where Render can shine. In an exciting development for the AI community, Emad Mostak, the founder of Stability AI, recently joined Render as an advisor to the network. Stability AI is world-renowned for their open-source Stable Diffusion model, which produces incredible images simply using text input. Emad is a huge proponent in decentralizing and open-sourcing AI models, so we don't just end up with one God model owned by Microsoft or Google. Part of this partnership will also allow Stability AI's model to leverage the provenance system already established on the Render network. This proof of render technology can provide a record of all the data ingested and used for output by the model. This transparency opens up avenues for royalties to flow back to creators whose IP and assets are used in AI models. This technology is already becoming increasingly important as we want the ability to discern AI-generated content from human-generated content, as well as to fairly compensate people whose work has created the data that can be used to train AI models. I'm extremely excited to see how this partnership progresses. I believe Emad's contributions to the protocol will go a long way in integrating the most complementary aspects of AI and crypto. Looking ahead, what does the world look like as we have higher fidelity images that are indistinguishable from physical reality? In each presentation the founders of Render put out, they always talk about their vision of moving towards the Star Trek holodeck. In the Star Trek series, the holodeck is a device that uses an advanced form of technology to simulate reality. These simulations create highly realistic, interactive environments that are indistinguishable from reality. This allows users to engage with the device for both training and recreational purposes. They can interact with simulated beings in virtual environments to provide a risk-free training environment where crew members can practice responding to various scenarios. It's easy to see how AR and VR researchers and technologists have been inspired by this concept in their real-world pursuits. Perhaps the closest we've gotten to actually replicating the holodeck is a technology produced by a startup called Lightfield Labs. Lightfield Labs uses a technology called solid light that produces the highest resolution holographic displays that have ever been created. These solid light objects have billions of pixels of resolution to present a hologram that appears to be in the same physical space as the viewer looking at the display. This technology could be used to create huge 3D entertainment experiences without the need of any pair of special 3D or AR glasses. While we aren't quite at the holodeck level yet, the advancements coming out of Lightfield Labs, along with the progress by Apple and Meta in AR and VR displays, point towards a clear trajectory towards higher resolution graphics. This might seem straightforward, but envisioning the sophisticated processes required to generate these ultra-realistic images is where the real innovation lies. With the Render network's growing arsenal of GPUs, creators of all sizes are equipped to redefine the limits of digital imagery. As we harness these tools, we edge ever closer to a future where digital and physical realities are virtually indistinguishable, opening up unprecedented possibilities for creativity, entertainment, and immersive experiences. We hope you've enjoyed this exploration of the Render network. If you're interested in us diving deeper into the Render network to take a look at their governance structure and tokenomics, please leave us a comment to let us know. Thank you for watching.